So we're going to do chapter 6.1, which is operations with functions. So we're going to talk about how to add, subtract, multiplying, and then divide functions. Pretty simple stuff. But then when we get to composite functions, that is something new that you're going to learn today. How to do composite function, right? So that is something new, and it requires, like, you guys to really pay attention. Now, the first thing you want to learn is basics, notations, right? If you see me writing this on in your assignment, right? F plus g of x, that means I want you to add both functions. That means I want you to do f of x plus g of x. Okay? This is simple stuff. It's just notation that we're learning. Difference is subtracting. So if you see this f minus g of x, I'm actually asking you to do f of x minus g of x. And if you see this f times g, a dot, that means I'm asking you to multiply f of x and g of x. And the last one is, if you see f of a g of x, that means I want you to divide them. But then, you got to make sure that g of x is not equal to 0, because a number or any function over 0 is undefined. We can't have that, right? It's infinity. We're going to learn that in calculus. Okay? Now, some examples that I want us to work on to get the hang of it is, we have this here, right? I give you two functions. F of x is x squared minus 4, and then g of x is 2x plus 1. And I want you to find f plus g of x, right?
Wait.
So f plus g of x. So if I'm asking you to find this, all I'm asking is add these two functions. That's what we're doing, right? F plus g of x is combining this function by adding them, right? So that is basically x squared minus 4 plus 2x plus 1.
Wait. Still copy that over there.
All right, copy a little faster, right? So here we just combining like terms. So that gives me x squared plus 2x minus 3, right? So this is f plus g of x. You're just adding them up. All I'm doing is just adding things up. I am not doing anything that you've never seen before, so do not act surprised. Okay? Now, the next one, this is this. Minus what?
Pizza.
Hey. Quiet down. Settle down.
Oh, never mind.
So x squared minus 4 plus 2x plus 1, I'm just adding them, right? So I'm just combining like term. And I have f minus g of x. Now I'm asking you guys to subtract them, right? So this is x squared minus 4 minus, and now you can put this in parentheses, 2x plus 1, right? So you're just again combining like terms. We've done this before in the polynomials. We'll learn how to add them, subtract them, multiply them. So this is just composite functions. They are called composite because you are putting them together. You're creating functions out of two functions that are given to you. So this is x squared minus 4 minus 2x minus 1. And I'm just going to combine like terms. The x squared minus 2x minus 5. Alright? That's f minus g of x. And then the next one is multiplying these two functions. It's f times g of x like this. So this is a multiplication.
So you pretty much just change the signs. Just kind of.
Well, here you change the sign. All you're doing is just multiplying them. When you see, you just have to recognize the operation that has been asked of you, right? This operation here is adding them together. This is subtracting them. This is multiplying them. The next one will be dividing them, right?
And you put it in parentheses so you know it's not a negative 2x and it's minus 2x?
Yes. Because if I don't put it in parentheses, a lot of people forget to like make sure that the negative changes the signs here and here. Some people forget that, they just put minus 2x plus 1, and then you get the wrong answer. So I put in parentheses to avoid any problem with my sign. So I want to make sure I'm distributing the negative evenly between the 2x and the 1, because it's going to change this into a negative, and it's going to change this into a negative. Then we have f of g, f dot g, that means you multiply them, right? So that's x squared minus 4, parentheses, times 2x plus 1. Now this requires a little more work because we're going to FOIL, right? So it's x squared times 2x.
2x cubed.
That will be 2x cubed, right? And x squared times 1 that will be x squared. Then we have negative 4 times 2x minus 8x, and then negative 4 times 1 minus 4. Now there is nothing else that I can do here because I have x cubed. It cannot be combined with any other expression, right? Then I have x squared, that stands alone because there's no other term with the x squared. Then I have negative 8x minus 4, nothing else to do here. So I am technically done with f times g of x. Then the very last one is subtract dividing. So I have f over g. So f over g of x, that means I'm dividing both functions. So I'm going to have x squared minus 4 over 2x plus 1, right? So now there's a restriction that can be applied here. Because I said this here cannot be equal to 0, right? Because any number over 0 is what? Undefined. You can't have that. It's undefined, right? So we want to make sure, that 2x plus 1 is not equal to 0. We want to make sure that is true, right? Which means 2x is not equal to negative 1, and x is not equal to negative 1 over 2. Because if x is equal to negative 1 over 2, it's going to turn this into a 0, and we can't have that. So as long as x is not equal to negative 1 over 2, this is f over g of x. This is how you divide f divided by g of x. It's going to give you this. As long as x is not equal to negative 1/2. I'm adding this restriction for a purpose because we can't have 0 in the denominator. We can't have that. So to make sure we avoid that, we have to tell whoever's looking at this that x is not equal to negative 1/2. Does that make sense? It's a restriction that we must add. No, making sense?
No, I don't
Okay.
understand.
So you see I have x squared minus 4 over 2x plus 1, right? You see I have this, right? So now this is f of x over g of x, isn't it? Right, that's true. But the problem is this, 2x plus 1, x could be anything, right? X could be anything. But the problem is, since x could be anything, if I replace this x by negative 1/2, this is going to give me 0. And that is going to make this undefined. So I have to add a restriction. I have to say that 2x plus 1 is not equal to 0, right?
So x on the bottom can't be 1/2.
X cannot be negative 1/2.
It can't
Okay? It cannot be 1/2. I have to specify that.
And if it is,
If it is, then this is not true.
so it's undefined.
It's undefined. So my thing is, I'm just telling the general public that's watching, hey, f of x over g of x is equal to this, as long as x is not equal to negative 1/2. This is called a domain. You're going to see that probably in the next chapter. We're going to cover a domain. The domain of the function is the function, the values for which the function is defined, right? So the function is defined, this function will be defined as long as x is not equal to what?
Negative 1.
Negative 1/2. So I have to add that restriction, because if I don't add it, somebody will consider that x is here, and therefore that will be undefined, right? For all the other functions, there's nothing that will make this undefined. X squared plus 2x minus 3, you can put in any value there, it will stand,
Okay,
right?
so then how do you solve it now?
You don't solve it, that's it. This is
That's
it.
it?
That's
So
it.
if it's negative,
If x is negative 1/2, the function is undefined. We just have to make sure we let people know. For example, let me give you another function. If I give you a function like this, right? Let's say you have a function 2 over x, right? This is your function. So you just have to add a restriction. This is true as long as what? As long as
X doesn't equal 0.
x not equal to 0. That's what you're saying.
Okay.
So this is your final answer, but you just have to make sure you tell somebody x cannot equal to 0, because you're going to have 2 over 0 and that's undefined, right? Or another example, if I have negative 1 over x minus 1, what would be the restriction here? If I have this,
x cannot be equal to 1.
x cannot be equal to 1, right? Because x minus 1 cannot be equal to 0, which means x cannot equal 1. So this is a restriction that you have to add, just to make sure, right?
You're getting a phone call.
No, I don't mind them.
I'm so lost right
I'm
now.
still on this.
It went away.
Okay, So tell me where you're lost, because I want to address that specific thing that you're lost about.
Okay, I mean, how is it that you solve this? Because if you keep saying that you have to add the restriction.
Okay, I'll get to that. Okay.
Because the whole adding restriction thing got me confused.
It's not a day to do something.
All right. So let me show you something here, right?
It's never that it is.
I'm not, like, I don't know why.
So f of g of x, you get this, right? That this is equal to x squared minus 4 over 2x plus 1. Right? You agree to this, right? But now here's the thing. You could stop here, but the problem is this, right? With a rational function, you know what a rational function is, right?
Yes.
What is a rational function?
Rational function is something that
Makes sense.
essentially
Right? What is it?
makes sense.
A rational function is a function that has a denominator. A rational, right? A rational, okay? So we have, so this is a rational function here. You have a denominator, right? Now the problem is this. In mathematics, you can't have anything over 0. That's undefined, right? But the problem is, with this function that I have here, there could be a possibility that this would be equal to 0. That's all I'm saying, right? So suppose I replace x by negative 1/2, right? If I replace x by negative 1/2, I'm gonna get x squared minus 4 over 0, because 2 times negative 1/2 would be negative 1, and negative 1 plus 1 would be 0. So the reason why I'm talking about restriction is this. You have to, once you write your function, right, you have to make sure that the denominator is not equal to 0.
So would you always replace x by 1/2?
Not necessarily.
So how do you know what to replace it with?
That's where I'm gonna get that. If you let me get there, I'll
If
get
it
there.
makes the bottom one equal to 0, it
So what you want to do is this. You want to say that 2x plus 1, you do not want 2x plus 1 to be equal to 0, right? That's what you want at all times in this specific case. You do not want this to be equal to 0, right? Why don't we want it to be equal to 0?
Then it's undefined.
Exactly, it's undefined. So that means now I'm going to solve for x. I know that 2x plus 1 cannot be equal to 0. I want to find the x value that's going to make this not equal to 0, right? So I'm going to solve it with 2x not equal to negative 1. And then x is not equal to negative 1/2. So I'm going to say f of x over g of x is x squared minus 4 over 2x plus 1 if x is not equal to negative 1/2. That's the restriction. That's all we do, okay?
You just write that.
We do not, you just write that down and say you do not want x to be equal to negative 1/2, because if x equals negative 1/2, it makes the denominator 0, which gives this the undefined tag. Does that make sense now? We good? Alright, so now we're going to move on to composite functions, right? You want to write this down? Go ahead. Right, now we're going to talk about composite functions. Now here, I'm gonna need you guys to really pay attention, because you've never seen this before. Okay? Now, basically, what is a composite function? The word composite, what does that mean in the dictionary?
multiple put together.
Putting things together, right? Composite is pretty much combining things, right? So with composite functions, the result of one function are used to evaluate the other function, right? That's what happens when you have composite function. You use the result of one function to evaluate another function. So how is that going to happen? First, we need to know notations, right? So when I write this, f circle g of x, I'm sure you've never seen this term before, right? What does that
Fog
mean?
of x.
Say it again.
Fog of x.
So what does that mean? So what does that mean? So we're gonna find that out. What does that mean? So it's called, we can use the term, there's two things that we can use here.
Is there a notation that I could use if I have O of x?
Excuse me?
If I have O of x, would I still use that same notation? It's confusing.
I don't understand your question. Can you write that down? So what are you saying?
So if one of my functions is O of x,
Yeah.
and then I
Oh, you know, I'm probably not gonna give you all facts.
It's only been one.
I get what you're saying. That was a good one. But I'm not going to give you that to avoid any problems, right? So f of g of x, so there's two ways to read this. You can read it as f round g of x or f circle g of x. That's what that means in terms of like, how would you read this? So f of g of this f circle g of x means f round g of x or f circle g of x. What does that mean? It's not just something that is just like random. It means something. So what it means is this: you are finding, right? You are finding f of g of x, and I will explain, right? So f round g of x is the equivalent of finding f of g of x, and I will explain now. So allow me to explain that. Okay? So let's say I have a function f of x equals to 3x plus 5, right? Let's assume that I have a function given, 3x plus 5, and I should find f of 1. What would you do?
I put 1 in for x.
You plug in 1 in for x, right? Plug in 1 in for x, so it's going to give you a 3 times 1 plus 5. You agree with me, right? Everybody agrees on that. We all good on that, right? Now, what if I ask you to find f of, let's say, f of t? What would you do? Put t in for x, I will give you a 3t plus 5, right? All right, now, let me ask you to find f of g of x. What would you do?
Put in G for X.
Put in g for x, right? You'd be 3 times what?
G.
G of x plus what? 5. That's basically what this means. So if I put f round g of x, I'm asking you to replace g of x into f. Wherever you see an x value. That's all I'm saying, right? So, excuse me?
You just replace it and that's it?
Just replace it and then now, if you know g of x, you can replace g of x by its actual value. We're going to do some examples here and that will make sense, right? Now look at this one. Look at this one here. So f of x is given. What is f of x? 3x minus 1, right? And then g of x is also given. What is g of x?
X plus 5.
X plus 5, right? So now I want to find f round g of x, right? So what am I going to do here? Using,
3x minus 1 and put in x plus 5x.
actually, you go the other way around. So first, let's use like simple notation, right? F round g of x will be me saying, I'm finding what? F of what? Gx. You see, we're going step by step. So f circle g of x, meaning I'm finding f of g of x. And now, to find it, I'm going to do what? I'm going to take this guy and I'm going to plug in where? Right here, right? So I'm going to go step by step. First, I'm going to go step by step. I'm going to go, this is 3 times what? G of x minus 1, right? And then, do I know g of x? What is g of x? X plus 5. So now that becomes 3 times x plus 5 minus 1, right? And then now from here, we can calculate it, right? So that becomes 3x plus 15 minus 1, and that is 3x plus 14. So when I'm asking for f of g of x, f round g of x, all I'm saying is this: take g of x and plug that into f. Does that make sense? So now I can go back, I can switch it up. Now what if I ask you to find, let me put it over here. So using the same example, right? 3x minus 1, so f of x is 3x minus 1, and g of x is x plus 5. Now I want you to find g round f of x. What does that mean then? Yeah.
G
Mm-hmm.
parentheses F parentheses X.
X. Right? That's what that means. So now how would you do it?
You plug in, so it would be X, so it would be parentheses 3x minus 1 plus 5.
Yeah, good. But before we do that, let's go step by step. I'm going to replace x by what?
F of X.
So it's going to be f of x, right? plus 5 because all I'm doing is I'm taking this guy and I'm replacing it in here, right? And then now I know what f of x is. So it's what? 3x minus 1 plus 5. All right? So that's it. So that becomes 3x plus 4, right? So g round f of x is equal to 3x plus 4. All right? So that's basically what we're doing in this chapter. It's called composite functions. Taking one function, plugging that function into another one, and then finding what it is. So now let me give you another example and see how we're going to do this one. So let me assume that f of x is and then g of x is let's say x plus 1, right? So first I want you to find f round g x. Go ahead and figure it out, see what you get. So let's find f round g x using that method. Let's see what that's going to give you. So f of x is x squared minus 2x, and g of x is x plus 1, and I want to find f round g of x.
Do we have some work on this today?
I'm contemplating that. So I want you to do this for a reason. So let's go ahead and find that.
Come on, marker.
Yeah. All right, so I want to find f of g of x. So tell me how you do it.
I did.
Mm-hmm.
Well, I just skipped. I just put the numbers in.
Yeah, go step by step.
Okay.
So it'll be what? F of what first?
F of g of x.
All right, and then?
And then it's f of g of x squared.
So it'll
I
be
mean
what?
gx squared.
Gx squared, right?
Minus 2 times gx.
Gx, right? And now we can replace this, right? We know what gx is. What is gx?
So x plus 1 squared
So it'll be x plus 1 squared.
minus 2 times x plus 1.
All right. So this will be x plus 1 squared minus 2 times x plus 1, right? Yes?
Yeah, I did this wrong.
So all you're doing again is just taking this gentleman and you're going to plug it in wherever you see
You're not
x.
solving it?
Wait,
You can go ahead and solve it. Like once you get here, you can go ahead and solve it. Right? Finish and expand it.
X squared minus.
All right? So go ahead and expand it. Is that marker like, see if you can erase that. I don't know if that's like, is it?
Yeah, maybe.
All right, well, get the hand sanitizer. Oh, no, use this wipes.
It's mostly.
You can use a marker.
Wait, let me see the marker.
You can use another
Does
marker.
it smell
It's
good?
mostly temporary.
Sniff it.
All right, go ahead and.
This is permanent.
All right, so now what I want you to do
Oh, pass it down. That's good stuff right there.
is I also want you to find, right?
How do you,
I want you to
wait, Mr.
find
Swan,
g of,
I have a question.
yes.
How do you determine whether it's going to be
Just so wet.
f g of x or
I
g
gave it
of
to you,
x?
I gave it to you.
What's the first letter?
So you gotta look up the way it's written, right? Here, if I have g round f of x, what am I asking for here?
No, sir, I was gonna ask, could you write the same problem in g of x versus f of x so I can see the difference? 'Cause I'm finding it-
Excuse me?
Could you write the same problem in g of x versus f of x so I can see the difference?
I don't think I understand your question.
She's asking you to write both.
Right, could you write the same problem in both? So I
That's
can
what he's
see
doing
the
right now.
That's quality stuff.
He's doing g of x.
Yeah. So
Wait,
now,
is that what you asked for?
now if I have g round f of x, right?
Look, you just did f of x.
I just did the f of x, right? So now I'm doing g circle f. So basically I'm asking for what? G of what? F of x, right? So that's what I'm asking for. Which means now you're gonna take this guy and you're gonna plug it in where? Here. So this will be g of f of x now will be what? F of x plus 1, right? G of f of x will be f of x plus 1 because what I'm doing is I'm taking this guy and I'm gonna plug it in here, right? That's what I'm doing in this case. I'm taking that, what it says, and I'm replacing it by x in the other function. Right? That's all I'm doing. Not like it's not that complicated. And then, now I know what f of x is, I'm going to replace it, so that becomes x squared minus 2x plus 1. Alright? So this is how you will do g of f of x. So now when we do this, we do have to look at the domain, right? So, let me ask you a question here. If you see this function, f of x equals to x squared minus 2x, what do you think the domain of the function is? You know what a domain is, right? Yeah.
Do you have to make it equal to 0?
Now, here, it's a polynomial, right?
Is it 2?
So, for all polynomials, for every polynomial, the domain is all real numbers. Is there anything that's going to make this undefined? No. Not a single value that you plug in here is going to make this undefined, right? For all real numbers, this is always going to be defined. If you look at this function as well, g of x equals to x plus 1, right? There is no value for which this does not exist. So the domain of this function is all real numbers.
So
Yep.
if it was x squared minus 2x over x plus 1, would the domain be -1?
Over, yeah, it'd be negative, all real numbers except -1,
Okay.
right? But here the domain is all real numbers because there is no value for which this does not exist, all right? So now, I also want to give you another example here. So, actually, I want to sit on this for a little bit.
Maybe we should do it
Where are
tomorrow.
the tissues?
What?
My desk is soaking wet.
Excuse me? Huh?
Can you explain the last part?
Yeah, I'm gonna give you some examples. So let's say we have f of x, right?
Excuse me, Mr. Salami.
Yes?
Whenever it's convenient, I have something for Patrick here in the front office.
All right.
Thanks.
Great.
Your birthday present?
Yeah, why do you have the office?
So the question is saying, right? Yeah?
Why did you?
Yeah. So let's say we have this, and I say find
Troublemakers.
find f circle g of x. Also find g circle f of x, and then I also want you to find f circle f of x, right? So let's do this 3 problems, and then the next question is if they exist, right?
You did not. Oh, you suck.
So find these 3 if they exist. So the first thing we want to do is we're going to look at each one of them, right? If I look here, I already know that the domain of this function will be all real numbers. There is no values for which this is undefined, is there? Is there any value for which this is not going to be defined? This is going to exist not, right? Because for any value that you put in here, you're going to be able to find it, right? Here, anything that you put in here, you're going to be able to find it, right? X minus 6, if you put in any number from negative infinity to positive infinity, it's not going to make this non-existent, I mean, right? Same thing with this one, right? So that's that. Now, if I want you to find, why y'all playing so much down there? This is serious stuff. I don't want to hear tomorrow, I don't know how to do this. Nobody's taking notes. All y'all, so I don't want to hear. I'm serious, yeah? Yeah. If I don't want to hear tomorrow, so if you can't do the homework, it's going to be on you, not me. So now I want to find f round g of x, right? So if I want to find f round g of x, basically, again, this, right, is f of g of x. That's what I'm finding. F of g of x. So what I'm doing now is I'm taking this guy and I'm replacing it here. That's all I'm doing. And then I'm finding the domain of that function. So that's going to be g of x squared plus 2, which is x minus 6 squared plus 2, right? And then I won't mind if you stop here. You don't need to explain it. That's fine. You can stop here, right?
The next thing makes sense.
I'm telling you today, this makes sense right now, but tomorrow I can't make any promises.
So now g round f of x right, is basically g of f of x, right? So what you're doing is you're taking f of x and now you're plugging in into g. That's what you're doing now, right? I'm taking this whole thing, and it's going to be plugged into whatever I see an x value. Okay? So that's going to be pretty much f of x minus 6. And now I know what f of x is. I'm going to replace it. So that is x squared plus 2 minus 6. Now I don't stop here for this one because I know I can combine 2 and 6. That gives me x squared minus 4. Right? And now lastly, I have
F of x.
yeah, now I'm doing f round f of x, right? So I'm doing f round f.
So you're just plugging the same equation in for x.
I'm plugging the same equation, so I'm taking this guy, right? And I'm plugging it into himself, right? You're plugging that function into itself. So you're basically doing f of x, right? So it's gonna be f of x squared plus 2 because I'm taking f of x and I'm plugging it back to itself. So that's gonna be x squared plus 2, the whole thing squared plus 2, right? So you're taking f and you're inserting f of x back into itself. That's all we're doing here, right? You're taking one and you're reinserting it into itself. So that gives you f of x squared plus 2, which is x squared plus 2 squared plus 2.
So
Okay?
x to the fourth.
You can stop here. Once you get to this point, you don't have to do anything else. Just stop, right? I don't need you to expand it because you'll be useless. I just need to know that you know how to actually get to that, right? I don't really need the rest. It's just fluff. Okay, so what I want to do now is I'm going to give you some work to do, and then tomorrow we're going to continue on with like these composite functions, but we're actually going to have like brackets, and we're going to figure out how to like use that because I don't want to do that today. So I'm just going to give you some basics